Glad to see you were able to find this video. I'd also be glad to hear from you. Let me know what you want to see or what you're having trouble with so that I can make content that's useful and meaningful to you. With that said, let's jump right in, shall we? Our previous video was the practice portion of our summary module, and the summary module is really the meat and potatoes of the orders of operations. This is where we took all of the different modules and all the different parts of the orders of operations and brought them together, and really we focused on the order. So it's not how do you solve brackets or how do you solve your exponents or your division, multiplication, or your addition and subtraction, but rather the order in which you solve them, because depending on the order, if you're not doing it in the correct sequence, you're not going to get the right answer. So it was really about trying to pull all of that together and making sure we're working on the order that they were solved. If you ran into any problems with any of the actual operations themselves, how do you go about expanding brackets or solving for an exponent, I suggest going back and looking at those specific modules. That's why we broke them out into different modules, so we would be able to focus on specifically how do you do this, so that way when we got to the summary, it was really more of what is the order to solve these in. Moving right along, this is the Q&A portion of our video series, and what we're looking at here is any of the questions that I got that I thought would be really beneficial for everyone to get a chance to see what the answers were. So let's go ahead and actually look at the first question. The first one is, what do you do if you have a negative beside a bracket? So sometimes you're going to have a sign or a number directly beside a bracket without an operation between them. So if you just have the sign, it's essentially saying that it's a 1. So if it's a negative sign, it's essentially a -1. And if it's a positive sign, so it's a plus sign, it's essentially saying a +1. And what we need to do is we need to expand that sign into our bracket. So we're taking the -1 and multiplying it into our content of our brackets. So the same thing would happen if it was positive. If it was a plus sign, we would take +1 and multiply that into our brackets. If you had just a number without a sign beside it, so let's say we had 6 with an opening bracket, we need to take that 6 and expand into our bracket. So we'd have to multiply. So let's take a look at an example. Here we have a negative sign directly beside a 3 and a 2 inside the brackets. Let me just switch my pointer so we can see that we're all talking about the same thing. So first off, we go back to our orders of operations, and the first thing we have to do is solve the brackets. So within the brackets, we have to check to see if there are any child brackets. There are no child brackets, so we can move on to exponents. There are no exponents, so we can move on to division and multiplication. There are none, so we can move to step 4, which is addition and subtraction. And we do have an addition. We have 3 plus 2. So 3 plus 2 is 5, and we drop the rest of the equation. Now, since our bracket is solved, we can take a step back and we can look at the main equation. We can go to see if there's anything else to solve. And there's no exponent, so then we can go ahead and move to step 3. And step 3 is division and multiplication. Now, specifically going right back to the question that was originally asked, what do you do if you have a negative sign directly beside a bracket, which we have? And what this means is we need to expand the negative into the 5. Expand means multiply, so now we're on step 3, so this is when we have to handle this. We're going to take this negative, which actually equals a -1, and multiply -1 by 5. So let's go ahead and write that out so we can see what it actually means. So the negative sign is essentially -1, and when you have a sign directly beside an opening bracket, it means expand, and expand means multiply, so we convert it to a multiple sign. So now we can go ahead and solve this. It's -1 times 5. A negative times a positive is equal to a negative, and a 1 times a 5 is equal to a 5, giving us a final answer of -5. So if you have a negative sign directly beside your bracket, it's representing a -1, and when you have something directly beside a bracket, you need to expand, and expand means multiply. Multiply is in step 3. Okay, I hope that answered the question. So let's go ahead and look at our next question. What is a nested child bracket? Okay, so this can get a little bit confusing. So what do we have when we talk about brackets? We have brackets that are on the same level as each other, and those would be considered siblings. They're siblings if they're on the same level. If you have a bracket inside of a bracket, then it's a child. And if you have brackets inside of brackets inside of brackets, those are nested brackets. So I like to think of the little Russian nesting dolls, right? You open the one doll and you have another doll inside, and you take her out and you open her up and there's another doll and another doll. Same thing with brackets, right? You have the outermost bracket and then you go inside and it has children. There are other brackets inside of it. And then so you can go into that one, and then there's another one nested inside and another one nested inside, and it just keeps getting deeper and deeper. So it can be a little confusing. So let's go ahead and look at an example, and we'll actually talk about which ones are siblings and which ones are parents and which ones are nested with when we have a visual representation. So here in our equation, I went ahead and I changed the look of the brackets so that way we could keep track of which ones are parents and which ones are children and which ones are siblings. So the first thing we want to talk about is the parent, and this is the one that has the parentheses. These are on the topmost level, and nested within, so brackets that are inside of our parent, we have children to the parent. So the relationship between the outside and the inside is that this is the outermost, and then this one is nested inside. It belongs to its parent. It's its child. And the children are right beside each other. Those are siblings, right? Because this is a child of this one, and this is also a child. They're at the same level. If there was another one inside here, which there's not, but if there was, it would be a child to this one, and then this one would be a parent, but it would still be a child in relationship to the outermost bracket. So it really depends on which bracket you're starting with to determine the relationship to another bracket, whether it's inside, it's at the same level, or it's above. So it's just a way of being able to communicate which bracket am I talking about. It can get a little confusing, but that's essentially what it is. Nested bracket means that there's brackets within a bracket. The parent is above, right? It's the outermost in relationship to the one that you're talking to. And then the child are inside, and you can have siblings because they're at the same level. And you could still have another sibling out here, right? If I had another set of parentheses, those two would be siblings to each other because they're on the same level. So it really depends on which is the one bracket you're comparing to another bracket to determine what the relationship is between the brackets. I hope that answers the question. Let's move on to the next one. What is a reciprocal and why do we need it? Okay, so this is a little bit of a tough one without getting into fractions, because it's essentially what we're talking about is fractions. So let's take a step back. All numbers are fractions, right? So they're all a part of a whole. So let's say if we talk about a pi, for example, we can say that it's of itself, right? So all numbers are essentially over 1. Without getting into too much detail of fractions. I don't know how far to get into fractions with this, but it makes me think I should do a video section on fractions specifically. What you need to know is that all numbers are above 1. And so what we want to do is we want to flip it to get the reciprocal. In fractions, sometimes you have like 1/4, and if you flip it, the reciprocal will be 4/1. And 4/1 actually gets reduced down to 4. So you would only show the 4. It's a little bit confusing. Let me know in the comment section below if you want me to go into more detail on this specifically. But essentially, all numbers are over 1. And we simplify it because we don't want to show more stuff than we need to, because it clutters up an equation. It makes it look more complicated than it is. It's the same concept of why we don't show the plus sign, even though it's there at the beginning of an equation. Like this 2 I have here, it's essentially a positive 2, but we don't show the plus sign because it just clutters it up. We know intuitively that the number is a positive. It's the same thing as being a negative or being a fraction, right? It is 2/1. We just don't show it. But the reason we want to flip to get the reciprocal is because sometimes it's easier for math if we just flip the reciprocal. It can get really complicated, and I think that's as far as I want to go without getting into too deep into fractions. If you want to know more, please let me know, and I can do a separate piece on this because I don't want to get too deep into it. Continuing along, I have 2 signs next to each other. Did I make a mistake? No. The fast answer is no, you did not make a mistake. Sometimes you're going to have two brackets that are going to be beside each other, whether it's how you've reduced your equations or if it has to do with brackets that come up against each other. There are often times when you're going to get two brackets, two signs directly beside each other. That does not mean you made a mistake. Here is a little cheat sheet on how to remember how to convert the two, because you want to make sure your equation is always as clean as possible. So if you have two signs directly beside each other, how do I go ahead and clean that up? Remember, a positive and a positive will result in a positive. A negative and a negative will also result in a positive because you're taking away part of the debt, right? It's a little bit confusing. We talked about it in the working with signs module, but so if the signs are the same, we're going to make it positive. If the signs are different, so if it's positive negative or negative positive, it's going to be a negative number. If you have any more questions on that, I suggest going back and rewatching the Working with Signs module. And if it's still not clear, please send me an email, put a comment in the video section below, or send me a message on Instagram, Twitter, however you want to reach out to me, and we'll try to clear this up. But no, the fast answer is if you have two signs directly beside each other, it does not mean you made a mistake. Help, I have an exponent of 0. Oh gosh, I didn't talk about exponent of 0 because it's hard and fast rule. Okay, so if you have an exponent of 0, your answer will always be 1. Okay, it can get really complicated, and I'm going to give you a high level explanation as to why. And we're really getting into math right now. Like, it's not like, yes, orders of operations is math, but we're getting into like the theoretical math here. So just stay with me here. If we break it down, what we're saying is that an exponent of 0, we're multiplying the base by itself 0 times. So whatever our base number is, we're going to multiply it by itself no times. It's just going to be the number, right? And if we go down a little bit further, multiplication is really just addition. So if we go down another level, what we're saying is we're not adding anything to our base. Are you with me here? We're multiplying the base number by itself no times because the exponent is 0, so whatever the base is, it's just the base. And multiplication is essentially addition, so we're not adding anything to it. The number is staying itself. And now something else to consider is 0 is a special number. It's called the additive identity, and it's the only number that can be added to a number without changing the value of 0. So if I add 0 to any number, you can use a calculator and test this. If you add 0 to any number, it's not going to change the value. Okay, keeping that in mind, we're going to go back up a level, back to multiplication, because we're talking about exponents, and exponents is multiplication, right? So we're multiplying. So if we go back up a level, the only number that you can multiply by another number to not change the value is 1, right? Because with 0, we had, for addition, it doesn't change the value, but we don't care about addition. We're talking about multiplication because we're talking about exponents. Exponents is multiplication. It's the base times the exponent. So we're looking at 1. So the only number that you can multiply by any other number and still not change the value is 1. And this is called the multiplication identity. So, summarizing it all back, if you have a base exponent, you're actually having 1. It's very, very confusing. Punch it in your calculator and you'll see that this is correct. This is a lot to remember, and it can be really confusing. Just remember that if you have an exponent of 0, you'll always be 1. Okay? Let that be the answer, and if you want a more in-depth example as to why this is, we can take a step back and we can dig into it a little bit more thoroughly. But that's essentially it. If you have an exponent of 0, you didn't make a mistake. It can happen. I'm sure you will come across another example of it. Just hard and fast rule, if you have an exponent of 0, your answer will be 1. Do you use the orders of operations if you don't have any brackets? So if I have an equation and I don't have any brackets, do I still have to use the orders of operation? Of course you do. You have been using the orders of operations since you learned how to do basic addition or subtraction. You're just not looking at the different steps because you didn't know about the other steps and they didn't exist within the equations that you were trying to solve. But regardless if there's no brackets, you're still always going to solve the operations in the order that they appear. So if there's no brackets, you're going to go ahead and look for exponents. If there's no exponents, then you move to your division and multiplication. If there's no division and multiplication, then you solve your addition. So always keep in mind that you are always going to use these. You always have been using these. When you first learned how to do addition and subtraction, all you had was addition and subtraction, so nobody had to tell you to look at the other things. And then once you started to learn your division and multiplication, then you realize you have to do your division and multiplication first, and then you do your addition and subtraction. And now it's starting to get a little more complicated. We have exponents and we have brackets, but remembering that if you can solve each step individually, I know how to solve for an exponent, I know how to solve for brackets, I know how to solve for division and multiplication, and I know how to solve for addition and subtraction. Remembering the order is easy. Just remember our acronym BEDMIS: brackets, exponents, division, multiplication, addition, subtraction. Your 4 steps, and you will always be using these, regardless of whether or not you have brackets explicitly put into your equation. How do you keep track of brackets when there are a lot of child brackets? Okay, so here are a few tricks that I have done in the past, whether it's me personally when I'm doing it or when I'm helping tutor other people, that seem to help with organizing brackets. So first things first, remember to solve one operation at a time, and then you're dropping the rest of the equation, right? We're solving one step and then moving through. Sometimes people will try to solve siblings. So if a bracket has multiple brackets on the same line, they'll solve both brackets at the same time, and I don't suggest doing that. Always do one step at a time, because that way it's easier to keep track of what you're doing. Second thing that you can do is actually underline the bracket that you're solving now. I can't really do it when I have it on the computer, which is part of the reason why I really suggest writing them out. But if you have a really long bracket, you can go ahead and just underline it so that way you can see what it is, and maybe do it like a curly line rather than a straight line, because a straight line might confuse you and you might think you have to do some division. So just keep that in mind when you're putting a line. I like to do either a curly line, or I use a different color, or maybe a wave or something to help distinguish the fact that it's not division. The next thing you can do is use different brackets. This is one of my preferred methods of how to keep track of my brackets rather than the underline, because the underline can cause some confusion with accidentally doing division. So if you use the different brackets, you have the parentheses and you have the square brackets and you have the curly brackets. And if you go ahead and just change the sets, maybe make the parent brackets always be the curved one, and then the child ones be the braces, and if there's any children within the braces, you can, or the square ones, you can use the curly ones. And this is just for you to easily see where one bracket starts and one bracket ends, so you can find the full length of your bracket. Something else you can do, if again you're writing it by hand, you can try using different colors for sets of brackets. So in the same sense of where you're going ahead and just changing the appearance of the bracket, you can go ahead and actually just use a colored pen. Maybe use if you're writing with black, or you use blue, or if you're using pencils, again, you can use a colored one, and just highlight, just redraw your braces in a different color so you can clearly see, oh, well, this one's a blue one, and then this one's also a blue, so this is the full length of my bracket. I hope those are some helpful tips for you, and some of them will be useful to you. If you have any other suggestions on how you keep track of your brackets, I'd love to hear them, because this can also cause some problems when you start having brackets within brackets within brackets. You know I love to hear from you, so if you have any questions or any future topic ideas that you would like to see, let me know. Reach out in whatever channel suits you best, and I look forward to seeing you at the next video.